architecture, but in this stage, the model can't do anything until we move to the next step. Until we train some huge of data to that model. It's called pre-training. But a pre-train have something wrong when you use. Example, I ask the model, hey, sort the number 537. The model can't answer properly. As you can see on the slide, model doesn't answer. It's just a continue my question. See? Okay, how to fix that? To fix that, we need to do the stage 2. It's called instruction fine-tune. Instruction fine-tune have a huge data also, but the format is usually in the Q&A question. So then we train it to the pre-trained LLM. Then we got the instruction fine-tune. Then if you use the same question, it should be respond correctly. So in the third step, I call it a preference fine-tuning. This stage is have to collect some data. Also, if you input to the model should to respond more than one response. So then we need some human evaluator to indicate which one is better, which one high quality. Okay, and then we will store to the database. If we correct enough, we train to the model with a method RLHF or the DPO. If you use some ChatGPT, you must see this screen that ChatGPT store your data to do that stage. Okay. Let's move on to the last stage. It's called the reasoning fine-tuning. It's similar quite stage 2 on the instruction fine-tuning, but it consists of some reasoning that contain a step by step, and then followed by answer. So this purpose is make the model can answer the hard question. So, hey, is there no continue pretend? What the continue pretend stage? Oh, the slide is loon. Okay, not a problem. As I know, the stage CPT is after pretend. Okay. Okay, as you know, the pretend state needs a huge of data. But how do you know which language that you train with the text corpus? I find some paper that estimates some language data that show me that more than 90% is English data on the Llama 2. But to be fair, a newer model has more than language than is. Okay. So, but why we need to train when you use some context like culture, legal, or bureaucracy related to Thai to the open source model, it's gonna be have some missing translation or some missing information, such as this is a flagship model from Qwen-based. I asked the model, hey, could you recommend the local Phuket dish? So as you can see, it recommend Phuket crab noodle, but if you can read the Thai, it recommend youก๋วยเตี๋ยวปู Phuket crab noodle should be in the ขนมจีนน้ำยาปู but the model name is ก๋วยเตี๋ยวปู the left ones as okay, the left one picture is ขนมจีนน้ำยาปู but the right one okay, the right one is crab noodle. As you can see, it's so different, right? That's why we need to continue pretend with Thai. So, what is catastrophic? So, properly, if you ask the model should be answered properly. But when I train it with Thai corpus, with a open source model, then it will train with Thai. Then it trained with Thai now. So if I ask the model that trained with Thai in the same, sometimes the model tends to answer with Thai, but wrong answer. As you can see, it's not a 537, it should be 357. Okay, the definition that's catastrophic forgetting is when a model learns new things, it forgot what is previously knew. Okay, so how to fix it? The first one is a simple approach. It is only a balance chunk of data. So let's introduce to my dataset. I call it dataset version 1 that we have a full dataset allow 16 billion token data. In a live one on here is our sample from this full dataset allow 2 million token in each category. Okay, let's move on to the evaluation that it seems to catastrophic forgetting. Okay, this is the Thai exam from the SCB. As you can see, it have a y-axis and x-axis. Hello. Okay, hello. The mic.
Testing 1 2 test.
Okay. As you can see in x-axis, it is a full data checkpoint 500 to the checkpoint 2269. So, as you can see, the yellow one is a score of the full data checkpoint from 500 to 2000. So, the green one is a balance dataset score that we use that balance dataset to train to the Qwen 2.5 and the orange one is a baseline. As you can see, after then we train to checkpoint 1000 is had to be catastrophic forgetting to Thai language. As you should know that Thai exam is only have a Thai question and Thai answers, but in the M6 but in the M6 exam it have an English question or it has English questions. As you can see, is the model that full data train is below the baseline. That's because if we deep dive in the M6 exam, in the subject English, it has a column on here is our catastrophic forgetting in English. Okay, and then we switch to the next evaluation. It's called XCOPA. XCOPA is one of the datasets that translate. That means if the model not have a skill that to translate, the model gonna be score is worse. As you can see, the full data is worse than the balance dataset and the Qwen 2.5 that is the baseline. So that's overall of the evaluation. Balance datasets model greater score than the full data every task, but the MMLU and XCOPA Thai is tend to forgetting a little. So the next export is I call it to data replay plus curriculum. Okay. The data replay is have some idea that open source had already 10 of web tech corpus already. Then why we don't need to retrain it to reduce the catastrophic forgetting? So I try it. As I show the evaluation to let's introduce to the dataset switch to. Okay, I have a web tech data called the 5 web Thai and 5 web English, and we have our own data that curate data allow the 8 billion token that break down right here. Okay, so then we train it all of data 63 billion to the Qwen-3 XP base. Okay, but the more checkpoint is lead to more catastrophic forgetting. So we have I list some of the papers called the reuse.retrain from NVIDIA. This paper separates the data into sorts. First one is called Pretrain when the dataset used to pre-train the model originally, and the second one is a QA, that's data I want to add to it. So that means the pre-train Ben is had a 55 billion token that have a 5-web English and 5-web Thai, but in a QA brain we have a curated data allow the 8 billion tokens. So this paper have experiment on the LR decay ratio, that the base ratio is max ratio over 100. As you can see, if I use the max LR as a 4.e times 10 minus 5, the mean LR, the base way it should be divided by 100. That means I used to be 4.5e times 10 minus 7. And the right one, what is the right one? The right one is the important part. So the right one is where we start with pre-train Ben and switch to the QA. So this paper use the LR scheduler as a target to point which LR you need to switch. So as you can see, the paper tests that the best performance is if you do in that 1/5 times max LR is the best performance that we change from the pre-train Ben to QA Ben that we need to add the data. So then we're gonna do on our data set. As we try, it's only need pre-train Ben only 45 billion, but I have much more. I have 55 billion, that much more than 45 billion. So when I try this method, it's not same as the best approach on this paper percent. So I shifted the spot that we need to switch from pre-train Ben to QA Ben to here. So as the right here is a 55 billion pre-train token Ben here and 8 billion token QA here. So this is an evaluation. This is only one evaluation of it because it is the only eval that have English. So why I show only one English? Because the catastrophic forgetting when use only the data replay is gonna be on the English data. As you can see in the yellow line, that is from the checkpoint 500 to the checkpoint 10,000. It tends to be loose and loose again. And as you can see on the data replay plus curriculum is have less catastrophic forgetting than the only use data replay and then shuffle is. The conclusion, or no, it's not conclusion, it's evaluation on overall, the data replay improve X-score time, as you can see, is much more in the green line, and reduce catastrophic forgetting in MMU English on here. But it has something to explore on the XNLI type, but why is lower than the both model from Qwen-based and based to data replay. And data replay a little high score on the Thai exam, MC exam, and M2 exam. It's only based on the exam only. I don't know why, but I need to explore more. So the conclusion is, if you can balance the category, you need to balance it. It's better even using less total data. And then if you want to scale up the data, you need to apply the replay and curriculum data training to prevent catastrophic forgetting. Limitation of this experiment is we use only Qwen and the maximum data size is only 52 billion tokens. Thank you.